Okay. So I hope you would have received your login. Okay. And let me do a quick recap of what we discussed in the last session. Okay. So we started with IDT, right? So we said that you have data, we have data in a backend database in several tables. So you need to build a universe using a tool called IDT. So IDT stands for Information Design Tool. So using IDT, we are building a universe and where we are going to define the data relationship between the data model we are defining uh, based on the tables. Okay. So can everyone hear me clearly? Uh, how about others? I hear from Harikiran that my voice is echoing. How about others? Okay, thanks, Rabindra. How about Krishna, Pavan, Tanzila, Jose? How about others? Okay, so Hari got disconnected, so let him enable audio. Meanwhile, so in the last session, we started creating a universe, right? So universe using the e-fashion database tables. Yeah, this is a new server which is shared with all of us. So I'll upload it. Yeah, I'll upload it. Yeah, yeah, Hari, Kiran, Har Kiran. Now, is it okay? Yes, Kiran. Is it okay now? You're on mute. Okay, okay. Yeah, thank you. So everyone is on mute. If you have any questions, please feel free to unmute and you can ask me. Okay, or you can ping me in the chat room. I can unmute you. Fine. So in the last session, we were discussing about this database e-fashion. Okay. So here, if you see, we have some set of tables. Now, on top of this database tables, I would like to create a universe. So that universe would be created using a tool called IDT, which stands for Information Design Tool. Okay, so these are the steps for creating universe. First, create a project, then create a connection from the backend database. So create a connection from universe to this backend database. It's a one-time activity. So if I create it and everyone can use the same connection. Okay, then create a data foundation. Then the next step, we are going to create a business layer and publish that business layer to the repository. So repository is nothing but our central BO database. Then once you create a universe, then comes the reporting part that would be handled through WebI. Okay, so open IDT, go to start all programs, SAP BI, and here we have client tools. Within client tools, we have IDT information design tool. So let's quickly navigate on the give me 1 minute. Okay. So here we have local projects, and then here we have repository resources, connection to the repository. So in case if you are using the tool for the first time, so this is how the, in case if you are using the tool for the first time, that's this is how it looks like. Okay. Now click on new project. Project is nothing but a folder to organize our objects, organize our universe objects. So quick question, what is repository? Can anyone answer me? So let's make this sessions very interactive. So that's how this online trainings will work. Otherwise, it would be very tough because we don't see face to face. I really don't understand whether you're following or not. So I would request every time I ask a question, so please reply very quick in the chat room. So that way, I'll be in a position to understand whether you got the concept right or whether your understanding is different from my understanding. Okay. So question now is, what is repository? Can anyone answer me, or can everyone answer me? Whatever you know, please use the chat room and respond. What is repository? Okay. Yeah. Thanks, Pawan. So one answer is okay. So we got different answers. Yeah. So I think the answer is from Ravindra is correct, but there's a small correction. It's BO doesn't store any data. That's a key thing we need to understand. No, sorry, Harikiran. This is not. This is the fourth session. Okay, so going back to background of BO is not possible in today's session. Okay, so I would suggest you to go back and or talk to the training coordinator, so he'll be able to help you with the previous session recordings. Okay, I'm very sorry on that because we have many other participants. It would be really boring for them. Okay, so if you want, we can discuss that at the end of the session. So the question is, first of all, what is repository, right? Repository is a database schema where all your objects, what we are designing in BO, we are storing, right? For meaning a central place, a central database, which will be connected from accessed for every user, from where we can access these universes and web reports. Meaning, say I'm designing this universe, okay? I create it on my local machine. So how do you all, let's say you are all our end users, okay? Or you are working along with me in the same project. So how do you all access the same universe? If I save the universe on my local machine, you will not be able to access that. So for that, what we do is we export this universe from my local machine. I will export this universe from my local machine to the central database of BO. So that is called repository. Remember, the repository is storing the business objects, the BO artifacts like universe, webby reports, crystal reports, etc. It's a central database. Remember, BO is not storing any data. Okay. So all the data is stored in the backend SQL server. okay, where data is stored in different tables. Whereas repository is a central database where the the business objects, BO objects are stored. Clear, everyone? It's not the project is different. Okay, the project in universe is different from a repository.
Hey Ganesh, a quick question actually.
Yeah,
Is business objects installed on top of any database?
yeah, it has to, right? Because if you need to store all the metadata, then it has to be installed on some database. So in this
So
case, if you see
what?
the SQL server,
Okay.
okay, so this is the data, all the tables of business objects.
Got it. Got it. Okay.
Okay. So now we are connecting data, we are bringing data up from this SQL server, okay, and we are presenting in the BO report. So in the training server, the same database is our repository, okay, but usually it's not mandatory that it has to be the same way, okay. So the BO can be installed on some other database, but that database will not store any data of reporting. So we are using this database just to store the metadata objects of BO. So this central database is called as repository, which will be used to share all the BO objects. Now going back, so first I would like to create a project. So give the project name and description. Sorry. So let's quickly go back and see the what are the steps involved in the universe creation. So to create a universe, we use this tool IDT. Just please hold on to your questions which are not related to the topic. Just please understand that I'll not be able to divert from the topic and explain you. Okay. So just yeah, we'll have this discussion at the end of the session or during the break time. Okay. So I'm just not finding words to quickly divert from here and there. Okay. Just a request. So we are done with one session. Okay, apart from the demo. Demo is just an introduction, and in the last session, we have completed a very basic universe. So going through the recording should be very quick to follow what we have discussed. And today's session is more or less a good recap of what we discussed in the last session. Okay. So yeah, going back to the topic. So these are the steps in the universe creation. First of all, what is universe? Universe is the data modeling layer. Okay. Once we bring data to the backend data warehouse, in the universe you design the data model, which makes the reporting flexible and easier, faster. And to create this universe, we use a tool called IDT. IDT stands for Information Design Tool, and this tool comes with BO4. Then if you ask me how about in the older version, are we not designing universe? We also design universe in the previous versions of BO, but using a different tool that is called UDT, which stands for Universe Design Tool, or in short, we also call it as designer. Okay, so this is the tool which is used to design universes in the 3.x version. The same tool remodified with a new interface, a new look and feel, navigations, and a better performance, and we call that tool as IDT. Okay, but the concept is same. How you design the universe, that doesn't change. So we are going to discuss both UDT and IDT so that at the end of the uh, universe designing, you should be comfortable enough to work on a universe, whether it is designed in 3.x version or 4.x version. So Let's first start with the latest tool. So once you get comfortable here, we can quickly go back to the old tool and you can compare. So to design a universe using IDT, which stands for Information Design Tool, these are the steps. First, create a project. What is a project? Project is just a folder to organize universe objects. So to keep all the related objects in one place. Then, like I said, Vivo is not storing any data. It has to connect to a backend database where we have the reporting data. Whenever you run the report, a Vivo report, data would be fetched from the backend system. Okay. So for that, we need to create a connection to the backend database. And this connection, we have to reuse this connection. So we need to publish it to the repository. Publish repository meaning the central database of Vivo. Publish is nothing but saving that in the database is called publish. Okay. Then create a data foundation. So data foundation layer is the one where the actual modeling work will happen. Then create a business layer and publish that. Business layer is your actual universe. So once we create the business layer, we publish that business layer to the repository, and then it will be the reporting will carry on. The reporting will start on the universe. So in this case, this is the database we have eFashion. So we have some of these tables. So we know that this is related to some sales data. Okay, if you see the here, we have like what is the sales amount, quantity sold, sales margin, okay, for different products in different weeks in different stores. If I want to create a new universe, I'll start it quickly again. So click on new, give a project name, click on next. So project name can be anything. So for example, I'll say SAP4 underscore eFashion. Finish. So nothing but a folder. Then once we create this project, the next step is to create a connection from Vivo to the backend database. We need to establish this connection from our local machine. Now, so before we create a connection in the universe, a ODBC connection, a driver has to be installed on our computer. Right? If you want to connect to SQL database, so drivers has to be installed. Now, if you go to see how to create an ODBC connection, so go to Start All Programs, SAP BI, Platform. Here we have 32-bit data source administrator. So what is this? Using this, we are creating a database connection. So if I'm an admin on this computer, I create a system DSN. Okay. So otherwise, you have to create a user DSN. Now let me create a system DSN because I have admin rights on this server. Click on add. So now based on the backend database, if you are connecting to Oracle, you need to make sure the Oracle drivers are installed. So if you want to connect to HANA driver is installed. In this case, I'm connecting to SQL Server. So if you scroll down here, you can see the driver. Click on next, finish. Give the connection name. This is just a ODBC connection name. So that can be anything. So for example, SQL underscore new ODBC. Description, ODBC connection to SQL Server. Okay. So if you want to connect to the Oracle database, you need to install Oracle client. Okay. If you need to connect to HANA database, we need to install HANA client. Okay. Then which SQL server you want to connect to? So this is the see all these are ODBC connections only. Remember, all these are ODBC connection only. But to create a ODBC connection, you need to have some software to connect to the database. So that software is called driver. Okay. See, to connect to HANA database, you will have some software. To connect to Oracle, you will have a different database. Okay, so you will have a different software likewise. Yeah, yes, this name can be anything. Okay, so client is nothing but a driver. Okay, so this connection name can be anything. When I say client, so Oracle client, HANA client, etc., it's nothing but the driver. Okay, so driver is nothing but a software to connect to the database. So this is the connection name. This connection we would be using in the universe ODBC connection. Then description, again it can be anything. So give a meaningful appropriate name. Then which SQL server do you want to connect to? So this is the computer where the SQL database is installed. So how do I know which SQL server it is installed? When you are logging into HANA, sorry, when you log into the SQL server, so that's what you see the details here. 192.168.1.4. This is the computer where SQL server is installed. So that's where we have our data, the eFashion data. Okay. Now give that server IP address or computer name. Anything is fine. So 192.168.1.4. Click on next. Then what are we doing? We are connecting to SQL server. Right. So we need to give the SQL server credentials. How we are authenticating? So using the SQL server authentication, a user ID and password created in SQL server. Now here I will go for this radio button. With SQL server authentication using a login ID and password. Then give the login ID and password of SQL server. What will be the login ID? So for all of us are using this a concurrent login. So you would be giving this login ID and password. Okay. So to keep it simple and unique for everyone, for SQL Server, even the user ID is case sensitive. So all these characters are in uppercase, capital letters. Okay. So give that ID and password here. So BO user in capital letters, password. So when you are connecting to SQL Server, also same thing. So here the user ID should be in capital letters, and then you can just remember password so that you are not bothered to enter the credentials every time. Then click on next, and say finish. So we created a ODBC connection. Click on test data source. Test completed successfully. So what did we do now? So we created a ODBC connection to SQL Server. This is the driver name. Okay, so this is the driver for HANA. Now this ODBC connection we are going to use in the universe. Now right click on your project in the IDT, new, create a relational connection. So we are connecting to this SQL server using we are bringing data from this SQL server using a SQL query. So it's called a relational connection. So I'll discuss about OLAP connection in the coming sessions. Right click and say click on new relational connection, which is firing an SQL query on the database. Give the connection name. Again, this connection name can be anything, but follow the naming convention. From the connection, we should be clear that to which database we are connecting. Okay, so SQL Server underscore ODBC. Give a description. So ODBC connection to SQL Server. Which SQL Server? 192.168.1.4. So this is just for our reference. Okay, it's not mandatory, just a connection name and description. Click on next. Now here we can see the list of backend databases which are supported. Okay, so using ODBC connection, we can connect to using ODBC connection, we can connect to any database, Teradata or HANA. Okay, like Oracle, Netezza, all these databases you can use. Okay. Yes. So all these databases, SQL query would be used. Yeah. And what is the next question? Do you have to remember all this name? Which name? This name can be anything, right? So there is nothing we are giving it. This name can be anything. Okay. So this is just a description. Click on next. Then we are connecting to SQL Server, which is from Microsoft. So when I open Microsoft, you will find the databases and relevant version from Microsoft Expand 2008, because our database is 2008 version. How do I know? You can go to help and about, somewhere you can see 2008 R2, right? Now we are connecting through the ODBC connection. Okay, ODBC driver. Click on next. Then the ODBC connection which we created now. Okay, what is the ODBC connection which we created? SQL new DBC. So that you will see. If you don't see it, you can select it from the drop down. Now give the user ID and password of SQL Server. So first step, what did we do? We created a ODBC connection where we selected the driver. Okay. We can also use the other type of connections like JDBC, OLEDB. Okay. We'll discuss that. Okay. So these are different ways to bring the data. For example, JDBC is using Java driver. Okay, it uses Java connection. ODBC is open database connectivity. Okay, so to connect to a database, you have multiple options. So yes, like we have. So to answer your question, we can also connect through the other JDBC and other driver. Okay, so it also depends on basically which operating system we are using, but both connections are supported. Now select the ODBC connection which we created in the first step. Then give the user ID and password of SQL Server, because we are connecting from universe to the SQL Server. So this connection we are establishing. So you are connecting to the database. So give the SQL Server credentials, which would be just now which I discussed. BO user. Test the connection. Test is successful. Click on next. Take all default parameters and finish. So we created a connection to SQL Server successfully. The extension for this connection is .cnx. You can see, you can you can go to the show values, and you should be able to see all the list of databases, what you see here, right, based on our authorization. Now if I go to the required database, fashion, so this is the schema DBO. We have these tables. Let's just, you can do a quick query, double click to preview the data. So we are able to see the data from this we are able to access the data from the database. So no security issues. So schema is nothing but how you are separating your data storage. Within one database, you want to separate the storage, you will use the schema concept. Now, the connection which we created is a local connection that will have an extension CNX, meaning this connection is only accessible by you. If I have created a connection on my computer, this connection is only available for me. So now what we need to do is we need to publish this connection to repository, the central database. What is repository? Central database. Publish meaning the connection which is there on my local connection, I will save it in the central database. That central database is called repository. That saving process is called as publish. To make the connection reusable for everyone and to apply the BO security, we need to publish the connection. So how do we publish? Select the connection, right click, click on. So here you'll find an option, publish connection to a repository. When you see this window, okay, it means that you are connecting to you are using this tool for the first time. Now you want to connect to the BO repository. Now you need to give the BO credentials. Okay, the system name where BO is installed. So on the training server, both are same. Okay, but it's not mandatory that in your project landscape, both your database of your data warehouse and BO is installed on the same database. It need not be that way. Okay. So 192.168.1.4 is the host name. Okay. So host name where BO is installed and also SQL Server is installed, both the same in this training server. Then user ID and password of BO. In this case, the same, but for BO, the user ID is not case sensitive, and no harm if you give it in uppercase also. Okay, and authentication, always keep it as enterprise. There are different type of authentications which we will discuss in the coming sessions. Okay, so sorry, it's not 1.14, it is 1.4. Yeah. Thank you, Pawan. Okay, it's 1.4. Yeah. So what is this system name? System name is the computer name where business objects is installed. So this is a user ID password. Click on connect. Okay. Now, so one very basic question: what is the difference between a database and a data warehouse? Okay. A database can be used for transactional systems. A database can be used for data warehousing purpose. Database is just meant for storage. A data warehouse is that can be a database where you are storing the data in a format which is good for reporting. So now going back to the publishing the connection, publish connection to repository. What does it mean? The connection which I have it on my local machine, I'm saving it in a central database, central server. That is nothing but the BO server. So right click on publish connection to repository. So now we have already connected just now, so those credentials are already saved. So click on next. Now you will see the folders which are in the repository. So remember in the last session we created one folder. Here is the option. So if you want, you can create folders create subfolders in the folder BOT July. Okay. Now I'm going to publish this, finish. Now it says the connection is published successfully. Do you want to create a shortcut for this connection? Yes. Okay. So you will see two connections here. With the extension CNX, it's called local connection. The .cnx secured connection .cns. Now click on new. I would like to create a data foundation. Again, data foundation name can be anything and a description. So I'll give the name as df data foundation underscore e-fashion. Click on next. Single source or multi-source. Okay. Now this universe is using some tables in the backend. If the universe is designed with some list of tables and all those tables are within one database, then you will create that is called a single source universe. When there is a need to design a universe where the required tables are spread across different databases, so that is called multi-source. So now in our case, all the data is there in one single database, right? So we'll talk about the multi-source universe in the coming sessions. So now I'll proceed with single source. Click on next. Select the secured connection. Okay. So the local connection is used only for publishing it. Once you publish the local connection, you can go ahead and delete that local connection, no problem. So go ahead and use the secured connection. Finish. So the data foundation will have an extension dfx. Now in the data foundation, this is the connection we selected. When you expand, you will find the database and the list of tables here. Now design the universe. So here I'll take these tables. So here we have one table with the name shop underscore facts. So in the last session we discussed what is a fact table. Fact table is a central transactional table which holds your measures. What is a measure? Quantifiable data. Okay. So numerical data on which we do our calculations. So in other words, we call it as a key figure measure. Okay. So everything is same. Quantifiable data. So here we have the transactional data in one central table that is called fact table, shop underscore facts. Now I have some other tables like master data tables, like product, store, time period. Now, so here we have the product ID, okay, and we have other information related to product like product name, product category, product line, etc. So if I want to analyze this amount sold, that is revenue and quantity sold by any of the product dimensions, okay, so I'll do a join from product ID to product ID. So by default, it's going to be an inner join. So double click. So you'll see article ID in table 1 equal to article ID in table 2. Okay. So by default, it is an inner join. Then we need to specify the cardinality. Okay, cardinality meaning how these two tables are related. So here in the product table, article ID is the primary key because article ID is nothing but products. So this is product master data table. And here you can clearly see we are storing the sales for the same product in different weeks, different stores. So here it's a foreign key. What is the relationship? 1:n. Okay. So either we can specify the cardinality manually, okay, using this drop down button, or simply click on detect. System will look into the data into these tables and define the cardinality. Okay. So as long as some proper data is loaded into these tables, detect will automatically give you the right cardinality. Only in scenarios where let's say you have loaded very few table records, then the cardinality might not be set correctly, or if it is some junk data, etc. So same way, now going to the other table, time period. Okay, in the fact table we are storing the sales, revenue, and amount sold by week ID. If I want to analyze this data by year, quarter, month, what I'll do is join this week ID with this week ID. Now right click, and then you can also directly detect the cardinal, specify the cardinality here. You don't need to go to the join, right click, say detect cardinality. Same way, now here, okay, I have shop ID.
Ganesh, I have one small question here actually.
Yeah, Krishna.
Uh, s- so when you click on edit join, there is some function called as validate. Means I was trying to create this kind of thing on club database that you have.
Yeah.
So will this validate really check whether the cardinality that we have specified is it right or wrong or
No, this validate will check the join condition.
okay.
With this join condition, we can see here automatically we are just joining week ID with week ID. You can go to SQL and you can write your own SQL condition here.
Okay.
Okay, so the validate will validate this expression.
Okay.
Okay, in case if you have written any custom SQL, so that SQL syntax would be validated here.
Might be because club database was unable to detect the cardinality actually. So I don't know whether this is junk data or I'm not sure. So
There is one empty table in that club database. Okay,
okay.
so that might be the reason.
Yeah, I haven't checked the data in each table, but I'll take a look at it. Thank you.
Yeah, yeah, sure. Okay. So now the next table we have is store. Okay. Now what we have in this table, we are seeing what are the total list of stores and which city the store is located, which state, who is the manager operating that particular store. So in case and again in the fact table we are storing this revenues by store. If I want to analyze the data by what is the revenue by state and city, what I need to do, I will do a join from shop ID to shop ID. Okay, either you join it from left side or right side, it doesn't matter as long as here you can see the join condition is inner join, right? Detect cardinality. Okay. So here we have defined a data model. Save this data foundation. Okay. Now,
Are there any restrictions on number of tables you can join? Means I know that affects the performance, but are there any restrictions?
no restriction.
Okay.
Yeah, as long as the joins are executing fine and the require based on the tables, there's no restriction on the tables.
Okay. Thank you.
So now I have defined a data foundation. Okay, data foundation will be even more complex than what we see here. Okay, we'll slowly add some more tables and increase the complexity and discuss various other functions one by one. So now here we have defined a data foundation where we have defined the data model, how these tables are related to each other. A very simple thing we need to understand is using the universe and Webby reporting, what we are doing, instead of manually writing any SQL code, we are making the system generate. Okay, we are making the system generate the SQL code automatically. Okay. So the next question here we have is we are going for this cardinality check, right? So this cardinality check. So if I go by this detect option, how good it can be, meaning will there be any scenario where this detect will give in this incorrect cardinality? Okay. See, as long as some proper data is loaded into these tables, cardinality, the detect will always give you right option. Okay. So, but let's say on the development system, there are only like 5 to 10 records. So there are some junk records added in the transactional table. Then the cardinality might be set incorrectly. Okay. Otherwise, the detect will automatically take care of the cardinality option. Okay. See, you can do one quick thing. You can just see the data. Right click on show table values. So it's a good indication that I have some 200 records. Right click and do a data preview, show table values. So now you can see here for every week ID, so I have one record here. Right click, go here, and I can see the same week ID is repeated so many times. Okay. So by looking into the data also, you can understand what is the cardinality. So, now the question is, do we need to understand the relationship between the tables? Okay. See, the cardinality might be set correctly, but this join, are we doing the right join? That is important. Okay. So let's see, for example, whenever you do a join, here this should be the primary key. Otherwise, what will happen to this measure? This measure will duplicate. For example, here we have two records with the same key, with the same product number. Just think of it that way. What happens? So one record here I have, which is amount equal to 100. After this join, you'll have two records for the same product, for the same amount 100. So it duplicates the value. Okay. So you have to make sure this join is a valid one. So now I have defined these tables. Save the data foundation. Here you have the save button. Now let me create a business layer. Right click on new business layer. So there is one option called HANA business layer, right? So ignore that for now, as the name itself says that is specifically used for HANA. So now I'll go ahead and create a regular business layer. What type of connection we create? Remember, we create the relational connection because we are using SQL query, ODBC connection. So now the business layer also will use the relational data foundation. So whatever is the business layer, that is our universe. I'll give the universe name as eFashion underscore T, meaning I'm just giving a suffix that trainer. Just because there would be so many eFashion universes, everyone would be now practicing the same example, right? So just I'm giving a unique name. So I'll say eFashion universe on SQL Server. Click on next. Select the data foundation. So here you will find a checkbox automatically create folders and objects. I'll uncheck it. Okay. Otherwise, so many unnecessary objects would be created. So it simplifies our job, but so many unnecessary objects would be created. So I'll uncheck it. Finish. Okay. So this is our universe name. A universe will contain classes and objects. What is a class? Logical grouping of objects. So you keep all the related objects in one folder that is called class. Then we discussed we have three type of objects: measure objects, which is quantifiable data; dimension objects, descriptive data; detailed objects are additional information about your dimension. Okay, so here we have data related to four different aspects, right? One is product, one is store, and one is time period. This is purely measures. Okay, here we have amount sold, quantity sold, margin. These are our measures. So now let me create four classes. That is a simply folder. Rename this folder. Double click. Use the folder name as product and store. Time period. Then one folder I'll keep the name as measures.
Ganesh, I think I forgot last time you gave me some explanation on like uh, can
What
I
is the
store
significant? Yeah.
everything on the same class or like so is there any kind of impact because I store every object under say one class only or something?
Yeah. So one thing is navigation. When you have so many objects, you keep all the objects in one folder. So navigation will become tough, right? For example, I want to look for one object. I need to search all the 30, 40 objects. So that is one thing. So basically these classes are designed for easy navigation. That is logic grouping. And then so when we drill down in the report, the drill down is based on the order of the objects we create in the class. So we'll see that in today's session. What is a navigation path, and how the order of the objects will impact the navigation path, and how we can disable that. Okay, so here we created four different folders. These are called class. Now add all the product related objects to the product class. And also when I add these objects, I'll follow a particular order. For example, state. Within a state, you have cities. So state is the parent object. Then I'll keep the child object. Then manager. If one manager can have more than one store. So instead of shop name, I'll keep it as store. Whenever we create these objects, create them in the business terminology. Then I'll add address, zip code. So what are these? These are attributes of store, additional information of store, detailed objects. Double click, or you can just say right click and say turn into attribute. Attribute of what? Store. Same way, zip code also I'll turn into attribute of store. Okay, so this icon represent that this is an attribute. This is a dimension object. So now I have followed a parent-child relationship here. State, city, manager, store. Same way here. So this is product line. Okay, family name. Double click. I'll rename this to product line. Then the product line code, I'll make this as an attribute. Then product category. Okay, attribute is nothing but additional information about the object which can be used to display the report, but you will not do any analysis by that. For example, if you see here, you will never run a report saying that show me the revenue by the address of the store, right? So by this address, this is the revenue. We will not do that. But the other way we can do is this is the revenue by store, and for this store, this is the address. Right? So that is a meaningful report. So that kind of data is called an attribute. The other data is an dimension object. It's a dimension. Then product. So instead of article label, I'll keep it as product. Then I'm going to add the product ID. Yeah.
Ganesh, just a quick question. What do you mean by analysis? Like, so now let us say I want a query that says like I want number of stores in a particular zip code. Let's say that's my requirement. So will turning the zip code into an attribute, can I achieve still that kind of query?
Yeah, you can achieve that, but basically you will for an attribute you can remove some of the additional information, additional processing time, etc. So for example, if I don't apply any filtering on a zip code, okay, so I can remove some of the list of values. So that kind of processing you can do.
Okay, so but still I can achieve my requirement, but you
Yes.
will not. Okay.
Yeah. So here we have product, the product class, then store, then time period. So I'll add year. So like I said, keep them in the business terminology. So some user community would be directly creating their own Webby reports if you give the universe. Okay. So not every user is end user is capable enough to create a Webby report on their own. Okay. But some user community would be well trained in Webby, so they create their own Webby reports. So we have to ensure that the universe is designed in a manner where the objects are very easy for the business to understand. So that's why we call it as a business layer, to create all these objects in the business terminology rather than in technical terminology. So and quarter, again I'll make sure that this object is named properly. See the values, click on show values. So quarter values are shown as 1, 2, 3, 4. Okay, so I would like to show it as Q1, Q2, Q3, Q4. Okay, so I would like to concatenate. See the data type of quarter. You can see AB. Now for some fields you see 1, 2. So that tells the data type whether it's numeric or character. So AB is character, right? So I can just simply do a concatenation. Single quotes Q plus the plus operator is going to do sum if both are numbers, else it will concatenate both are string. You can validate it here. The expression is valid. Then month, then month number, then week in year. Now let's add our measures. Okay, so margin, amount sold, quantity sold. I'm going to add them as measures. So when you add it, they by default they are added as dimension objects. So let's convert them into measures. Right click and say turn into measure with aggregation function sum. Now you will see a different icon added. Then you can double click and you will see that there is a sum function added here in the select. So I'll explain what is the requirement for that. But if you are good with SQL, it's simply a group by will be done on these objects. So instead of amount sold, I'll keep it as sales revenue. Okay, and you can see a differentiation in the object with the icon that this is measure, this is a dimension object. When you expand the dimension object, you will see detailed object. Save your business layer, your universe. Now you can validate your universe, you can test your universe by creating a sample query. Go to queries. I would like to see what is the revenue by state. So where is the information we have? So how do I, before we go ahead and create a query, so let's understand it from the table. So in this table, shop underscore facts, we are storing the amount sold by products, okay, by week, by store. So if I want to see the revenue by city, so that means so this join is required. And then we are storing the data by store for several products. So we need to aggregate the data by city. Okay. So let's go to business layer, create a query. How do I create a query? This is my business layer. Below I'll find a queries tab. Then click on insert query. So state-wise, city-wise, I would like to see revenue. Just do a drag and drop. Now, based on the objects we select, okay, then based on the object definition and the join conditions, joins in the universe, a script would be generated and a SQL code will be generated. So select state, city. Then for a measure, I showed you that there is a sum function added. So sum of amount sold from these tables and the join condition. Okay, shop ID in table 1 equal to shop ID in table 2. And then as we are using a sum function, the group by is automatically added, group by state and city. Click on OK. Now give some name. I'll say sales by state and city. Now click on execute query to see the outputs. So this is your revenue by state and city. Whatever the queries we are creating in ITT, this is just for our testing purpose. We are testing universe whether it's working fine or not. Okay, end user is not going to access these queries anyway. Okay, so then on top of this universe, we'll be creating a Webby report. Those Webby reports would be used by user. Okay, so that part we will slowly come to the Webby session. So now you can see we can preview the data. We are able to see the data. So now we successfully created one universe. Publish this universe because this universe is available only on my local machine. Now if you try to log into the BO system, you will not find this universe. Why? Because it is currently on my local machine. So to make this universe available for everyone in my team, everyone in the project, so what I'll do, I'll right click and say publish. Publish is nothing but saving it to the repository. Publish to repository. So before that, save the data foundation. Sorry, save the business layer. Now right click on publish. Okay. Click on next. So let's create one folder. Let's see if I have created one. So in the last session, I created one universe, the same one, UE function one. Okay, so I'm publishing the universe in the same folder with the name efashion_t. Universe is published successfully. Okay, now you can go ahead and do reporting on top of this. Okay, so question here. So how to add a measure in universe? Right, so measure or dimension, everything is nothing but a field. Okay, so I can just do a drag and drop, right click and say turn into measure sum. You want to create a new object. Okay, for example, based on revenue, you want to calculate some tax. Okay, so very simple, right click, select the folder, right click, click on new. I would like to create a new measure. So double click the measure, then give the uh, measure name, let's say tax. So go to select. How do you do the calculation? So revenue into 0.1. Okay, so this is called a calculated measure. And now every time you do changes to the universe, you have to save it and publish it back. Only then the changes will be reflected in the repository. So make sure you publish it to the same folder. So you are overwriting the existing universe. If you publish it to a new folder, what happens? Now the old universe will be there, and you are creating a new universe in a different folder. I'm going to the same folder and publish it. It will ask me, there's already a universe, do you want to overwrite? Yes. Okay. So this is a very simple universe which you have created. So now in case if there is a new field you want to add it to the universe, same universe, what do? We simply add it here, right? If the tables are refreshed, so let's say there is some new field added in this table. Okay, so first of all, let me explain the question. Question is how to add new fields from data warehouse to the universe. Now let's say a table got modified in the backend database So go to data foundation, actions, and say refresh structure. Okay. When you say refresh structure, it will show you what are the changes in the database. Okay, then click on next and then proceed. That particular change would be reflected in the table. Okay. Then go back to your business layer. Now, whatever you want to do, you want to add a new object, you can drag and drop, save it, publish it. Okay, so if you don't have the universe on your local machine, so this you don't have a universe here, you can always right click and say retrieve a published universe from the repository. Like for example, so I have created this universe. Now if you open the IDT in your login, definitely you will not find this project, right? And you want to modify the universe which I have created, so that's why I published to the repository. So what you do is you create your own project, right click and say retrieve a published universe from repository, log into the system, go to next. So go to the folder where I have published. select it and click on finish, it's going to retrieve the universe from the repository to your local machine. Now you do any modification you want, add a new field or delete a field or add a new calculation, save it and publish it again.
Ganesh,
Yeah, Krishna.
uh, I see that when you publish a business layer from local repository to the central repository, it's storing the name some UNX or UNV. I'm not sure.
Yeah,
But when
UNX.
you are not publishing data foundation separately, so will the retrieval get you the data foundation also?
Yes, yes. It's going to retrieve the connection, data foundation, and business layer.
Oh, all the three.
Yeah, yeah. Okay.
Okay.
So let's quickly do that. Okay. I'm going to delete all of this. Now right click and say retrieve a published universe from repository. Okay. Business layer, connection, and data foundation.
Perfect. Thank you.
Okay. So let's take a short break for 10 minutes. And then what I'll do is, so in the last session, I gave that assignment, right? So let's do that assignment. Why? Because that is very easy to understand. Let's complete that assignment and then I'll give you a different assignment. Okay. So we'll take a break for 10 minutes and connect again. Okay. Okay, shall we start the session? Can you all please respond to me?
Hey Ganesh,
Yeah,
yeah, I got a question. So, when we like for example, like if I want to start creating my own universe and all that, um, I wanted to ask. I can anytime I go in and try to play with it and see how I can start doing it. Can I delete it any time of the day? Like delete it and try a new one, and anytime I make a mistake or something.
yeah, no problem. As long as you're not dealing with some other universe, okay, no problem. Go ahead and do it.
Okay, I just wanted to know if that's possible.
Yeah, yeah, you
Okay.
can do it.
Right.
Can everyone please respond to me? So, shall we start the session? Is everyone back? Okay. So, in the last session, basically, I gave this as an assignment. So, but let's complete this today. Okay, why? Because this would be more easy to understand the universe concept. Then I can give a different universe as an assignment. Okay, so Krishna, Rabindra is there. Tanzila, then Jaya, are you there? Okay, yeah, thanks. So see here. So these are four tables we have. Okay, one is a product table. So this is a product ID. So product ID 20 refers to cap, some cap, and it falls under category accessories. Then 21 is a belt. So that is also under accessories. So you're grouping these two products into one category. Okay. Then there is another product 22. It's a jeans. It is some other category. Then so these are the list of customers. Very simple, easy to understand example. Okay. So we have six customers, customer ID and the customer name, and the country they belongs to. But we are not storing the country name, but we are storing some country ID. So there is another table, country table, which stores the country name. Okay, so meaning customer one is Ram from India. Okay, then there's an employee table where we are storing the employee ID, employee name, some name, and then again employee country. Okay, so country in which the employee is located, the employee belongs to. So if you see the sales data, now tell me what is this data? So customer one, Ram, purchased a cab, okay, and that transaction is handled by this employee, and the sales amount is 100. So likewise, so same customer, different product, same employee, etc. So this is the sales data we have. Okay. Now I would like to, based on this data, I would like to run some queries. Okay. So first let me save this file. Okay. Now, first report, I would like to see what is the revenue by country, by product category. Okay. So, how do I get the revenue by product category? See how many categories we have? Only two categories, right? Accessories and pants, right? So, accessories and pants. Now, under accessories, we have two products, 28, 21. Now, I'll apply a filter here. So, what is product? Which products? 20 and 21. What is the amount? 2400, right? And what is the other product? So let's remove this filter. $520. Okay. So this is one report I would like to generate. So far clear? And the other report is country-wise revenue. When I say country, the country of the customer. Okay. So you can see all the customers are from only two countries, country ID 10 and 11. So which is 10 and 11? India and USA. So India and USA. So now what is the revenue from the customers of India? Okay. How do I get that? So country ID 10. So which is customer 1 and 2. So this data which is marked in green, this is the data from India. So you can see the sum is 870. The rest of the data is from you from customers 345. All they belongs to USA. So that revenue is 2050. Okay, right? So this is another report I would like to see. Okay, then another report where I would like to see product category and country and revenue. So the revenue, the breakdown. Category, so product category and country and revenue. So this is another report I would like to create. So clear everyone on the requirement. So we'll create one universe on top of this, and let's analyze what happens. How do we validate this universe, etc. Okay. So first, let's upload this data. If we go to our server, for each of this, I'll create one Excel file. Okay. So I'll save this. Go to save as the D drive of the server, remote desktop. Okay. So there is, yeah, yeah. Yes. We can use the same Excel with different sheets and we can load. Yeah. Okay. So I'm creating in this particular file data. Okay. Or let's say, for example, there is one folder. Yeah, I'll save it in data. So I'll give the name of the file as sales. Okay. You don't need to use this file anyhow. Okay, because I'm going to upload this file to the database anyhow now. Okay. So this one I'll rename this tab to products. Okay. Then I'll have another tab with the employee details. Then customer details. Okay. Then the country information. Then sales. Right. So save this file. Now let's import this file, all these tabs into SQL Server. So SQL Server, now we created this database sales. Okay. I'm going to right click on this table, task, import data. Okay. So this is like a quick import. So I would like to import it from an Excel file. Go to the path. Click on next. So give the login credential of SQL Server. Click on next. So copy data from one or more tables or views. Next. So I want to copy all these tables. Okay. So the tab name is your table name. So you can rename this to. I'll remove this dollar. Okay. Then click on next. Run immediately. Finish. So it should have created. Okay, so these tables. Let's see if we have data in these tables. So product, right click on select. Okay, so we have data. So let's use this very basic data and create a universe and verify whether we are getting right results or not. Now, as we are getting the data from the same database, you can reuse the same connection. I don't need to go ahead and create a new connection again. Now, I'll create a data foundation. Right click on new data foundation. The data foundation name, I'll keep it as df underscore sales. Click on next. It's going to be single source. Now I'll use a secured connection. Finish. I'll directly go to the sales database. Add sales table. So that's where you have the amount, which is so which is a measure. Okay, then customer table, then employee, product. So if I want to see the revenue by product category, so what we'll do, we need to join this table. Product ID to product ID, right click, detect cardinality. Now customer to customer, detect cardinality, and then employee ID to employee ID. Okay, then add country table. So why? Because I have only country and country name is not there, but in the report, let's say I want to see data by country name. So I'll join this country ID to country ID. Okay, detect cardinality. Save this data foundation. Now I'll go ahead and create a business layer. Right click on new business layer. I'll say sales. Select the data foundation. I'll uncheck this tab. Finish. Okay. So we have only, also there are 5 tables, but this data is related to 4 different information like customer, employee, product, and sales. So I'll create only 4 folders. Customer, then sales employee, product, and then measures. So I have renamed these folders. So I'm going to add in the customer tab, in the customer folder, I'll add country. Okay, then customer name, and customer ID, I'm going to add it as a attribute. Then sales employee, I'll just add the employee name. I'll rename it to sales employee. Then product category, product, I will add the product ID. Okay, so here we have only one measure, that is amount. I'll add it. I'll convert this into a measure. So let's see, right click, say turn into measure with aggregation function, sum, double click, and then you will see and notice that there is some function here. Now give the measure name as sales revenue. Okay, save it. Now let's validate. So now if we create a query, and by this, like if you see data by product category, we should see this data, right? And if I see it by country, we should see this data. Go to queries, create one query. So first query, I would like to see the data by country. So country wise revenue. Now go to view script. Select country, then sum of amount sold. There are 3 tables involved here: country table, customer table, and sales. So those join, and then group by country. Here we can see the data preview. India 870 and USA 2050. So that's what we are seeing here. No, we are seeing, yeah, sorry, here 870 and 2050. So I give a query name as sales by country. Then one more query now by category, product category. Yes, sales by product category. Execute. So 2400 and 520. 2400 and 520. Yes. The values are matching. Now another query, so by sales by country and product category. Okay. So what is the total revenue for accessories? It is 2400. Now this breakdown by customer, by country. So out of that, 440 is from 450 is from India, and the rest is from USA. Right. So you can see all the data is matching. How the joins are executed. You can see the joins. Okay. So now let's publish this universe. Okay. Save the business layer. Right click, click on publish. Publish to repository. Click on next. Finish. Okay. So any questions on this?
Hey Ganesh.
Yeah.
Yeah, I got a question. So when you like if you go back to where the Excel sheet, so you have to create this for yourself, right?
No, no. See, this is just an example data. See how the data, how you will have this data, right? So you are asking in a real world scenario.
Yeah.
So in a real world project scenario, what happens? You have all your data created in the transaction system. So a ETL jobs will
Okay.
be running every day. So that's going to bring data from the transaction system and update the data in the data warehouse. Okay.
Okay.
So
My
yeah, our
biggest
job, yeah, our job will start as a BI
Mhm.
consultant after the data is updated to the data warehouse.
Okay. Now my biggest question is because, like I said, when I first started this class, is that this is my first time in the ASAP. So, do your client give you all this stuff like I mean like the chart sheet you showed on the Excel, like the products and all that? Do they give you that you use to create to create all this stuff you just created? Do they give you that, or you create this yourself?
See, we'll have the data already uploaded into the database. Okay,
Okay.
so that will be taken care by the ETL team. Now, our job will start connecting to the database. We don't connect to Excel. We don't write the data into Excel.
Okay.
We don't upload any Excel kind of thing. So why I did that is just that is very sample data which we created for our learning for our easy access. So that's where I'm going to I'll do this import data only for this training purpose. So we don't do that in the project environment. Okay. In a real world scenario,
Okay.
the database would be daily updated with the ETL tools, ETL tool which runs every day and brings data from the transaction system. So our job is to connect to the database, analyze what tables we have, how those tables should be joined. Okay, so it would be that way.
Okay. Thank you.
So your assignment would be to work on the club database. Okay. So go to this club database tables. Okay. Now create a universe on top of this. Out of this, what tables you need to do? Let me explain you this list of tables. So how these tables are connected. So you'll find one table called customer. This is the customer table. Right click on if you see the data preview. So you have customer name, age, phone number, address, etc. And you have city ID. Okay. So meaning I want to know which city this guy is from. So I need to go to the next table, that is city underscore local. So if I see a data preview from there, so city ID and city name, but which region it falls under, again there is a region table. Okay, I need to go to the region table. So from region I have the country ID. So I need to go to the country table. Okay. So if I want to know the customer city, region, and country, so I'm connected to a city table. This is further connected with the region table. This is further connected with the country table. Okay, so these are the joins which we need to create. Okay, so do this as an assignment. Connect this table. Okay, so this will give the customer information. Then this data club is related to some resorts. Okay, so if you go to a table called sales, we'll find the invoice details, like so the sales amount. So here we have invoice date, then to which customer this invoice is sent. Okay, so it's on this invoice is charged on which customer, right? So this I'll join this sales table with the customer. Okay, so here we have in the invoice table just the invoice ID. So in this invoice, so what services are charged? So that data is there in the another table, invoice line. So you can see for this invoice there are two services they are charged. So one service they used for 5 days, four people used that, and another service 5 days. Only three customers used it. So that's how we can do the billing, right? So this is connected with the invoice line item table. So in this line item table, we have a service ID, but I would like to know which service is that. So here you will find a table, service line underscore local. Sorry, it's not service line, it's service. It's service ID. So 211 refers to hotel room. Likewise, every service has the service ID and the service name. So then you can see multiple services are grouped under one service line. So this table would be connected with service. This is further connected with service line. So this is further connected with. So these service lines are available in which resorts. So these are the list of joins which you need to do in the data foundation. Okay, so this is your assignment. So go ahead and create a universe on top of this database. Create some sample queries like see revenue by, what is the revenue by country? How do you get the revenue? So invoice amount you need to calculate. from price of one service by number of customers using that service. So just look into the data. It should be clear, but anyways, I can explain it one more time. But try it once. Okay. So this is the universe which you need to create. So after that, if you have some time, you can start working on this motors database. Okay. So for now, just go through the data preview of these tables. Okay. Just right click and say do a data preview, and just try to understand what data you have in this database. Okay. So that would be your this is your assignment for today. So in the tomorrow session, we are going to discuss what is select level aggregation and projection level aggregation. And we'll talk about what is a loop, how to resolve loops. So what happens if a loop is not resolved? Okay, then customizing, and we'll talk about what is navigation path. Okay. So these are the topics which we are going to discuss in the tomorrow session. Okay, any questions for me for today?
Yeah, Ganesh.
So, yeah.
My question is, so the assignment that you gave us, the way you did it, you want us to exactly do the same way you just finished creating the universe and all the stuff you just showed us over the past 3 hours, right? Am I correct?
Yes. So yes, you need to start with creating a connection, then data foundation, business layer. So what all steps I followed on the e-fashion and the sales universe, you need to redo that.
Okay.
Okay. So you on the same steps, you need to create a universe on the club database.
Okay. I got it. Thank you.
So yeah, so in that database we have other tables as well, but for now don't use all of those tables. Just use the tables which I have mentioned in the PPT, and so PPT is uploaded already in the blog.
Okay. So do we need to check the assignment side area before we go and do it, or from what you just said, we should just go ahead and do it?
Yeah, yeah. So whatever I explained so far, that is enough. Okay.
Okay. All right. Thank you.
Yeah. So on the session recording, I think this will be available only on Monday, but you can check with the training coordinator.
So when is this assignment? So by next week Saturday that's when you would like to see this assignment, right?
Yes, yes. Next week Saturday. Yeah.
Okay, and then we post it on the assignment site.
Yes, yes, yes.
Okay.
Okay.
All right.
Once
Thank you.
once you complete the assignment part, post it on the blog. What you need to post it is you need to post it on the the folder and the universe name which you created, so that I can do a quick check and explain if you are missing anything.
Okay. All right. Thank you.